Okay, here is the question, and I want to plot the root locus, and this is the imaginary axis, this is the real axis, and these are the zeros, or there is just one zero at -2, and there are two poles. And if you do the math using the quadratic rule, so it should be, so 1 5 10 minus 2.5 plus minus 1.9. So I will write this down: minus 2.5 plus minus 1.9, 3 or 94. And then you will locate it over here. This is -2, this is minus 2.5, and now I will draw the root locus using the real axis, and then I will show you. I will put my pen down once I hit the odd number of poles or zeros. This is the first odd and zero, and it will keep going to the left. And according to the asymptotes formula, you can see that there are two poles and one zero. So I will just use, there is just one asymptote, and don't worry about finding the location, because we know there is just one asymptote to the -180. Now, in order to find out the angle of departure, you have to understand that, imagine there is a test pole here, a test pole, and this location is P1, or you can say this is P1, this is P2, and I want to find out this angle of departure from here, and this over here, and this over here. So this is theta 1, this is phi, this is, and this is theta d. Okay, according to the formula of characteristic equation, the angle of GH is equal to plus minus 180, but let's assume this is minus a 180. What are the rules? The rules: angle for the poles and zeros. I'm going to take this P1 in under consideration, so theta d would be negative, and numerate phi would be positive. In the denominator, the angle would be theta 1 minus theta d would be equal to minus 180. Now, what is phi? Phi is the angle from this, the direction, the first direction is S naught. S naught is like a pole, which is minus 2.5 plus 1.94 minus the zero location, which is -2. So it would be tangent inverse my this is J. I forgot to write down J here. This would be 1.94 over minus 0.5. So if you solve for this, let's do this. So arc tan 2D 1.94 comma minus 0.5. It is 104.45. So this angle is 104.5 or 45, 104.45, and then 104.45. And then let's find out what is theta 1. Theta 1 is from that test pole, which is very close to the vicinity of the angle of the pole where we want to find out the angle of departure, minus 2.5 plus sorry, not plus, minus sign, minus 1.94 J. So this would be equal to, this cancels out by this when your negative sign is multiplied, so you get 2 times 1.94 J, and the angle of J is always 90 degree. So theta 1, if you plug it in over here, now we have found phi, we have found theta 1. So let's use this equation in order to find out theta departure. Theta departure would be equal to phi minus theta 1 minus plus 180. That would be 104.45 minus 90 plus 180. That would be equal to 104. 180 plus the answer minus 90. 194. This is the angle of departure from that pole location. So this is the angle of departure, 194.45. If this is the angle for the P1 pole, then the other one would be negative. So theta departure for pole P2 would be negative, because complex conjugate, they always symmetrical about the real axis. So if I want to draw the root locus, about 194 would be here. It will come down, go here. This will be plus 194. Go up, go to the left hand side. So this is how you will complete this root locus problem.